Question 6. Jacob has 1200 in his account. Let's call this times 0. We'll do a 1 and a 2. He has 1200. So at the end of the next month, at the end of month 1, how much has he got in here? Well, he spends 90% of whatever's in his account. So there's going to be 10% of 1200 left. Plus, what does he put in? 1440 at the end of the month. So it'll be 1440, and after that, in month 2, we're going to have not 10% left of this guy because it was in there. So 10% of the first guy plus 10% of the second guy, and the 1440 he's putting in at the end of month 2. So we get 0.1 to the power 2 by 1200 plus, I think we can probably see the sequence starting here, can we? It's going to be 1440 times 1 if we reverse it around, and then there's going to be repeating 0.1s, 0.1 squareds. So this is my geometric sequence. A is 1 and R is 0.1. So Sn is equal to A times 1 minus R to the power of n over 1 minus R, which is 1 minus, on top, 1 minus 0.1 to the power of n, and 1 minus 0.1 on the bottom is 0.9, with the 1440 in front. 1440 divided by 0.9 is 1600, so it'll be 1600 times 1.1 minus 0.1 power of n. So that's going to be 1600 minus 1600 times 0.1 to the power of n. And the beginning of the sequence was 0.1 squared. This was when we were looking at month 2. We could go to month 3, but let's do it really quickly this time. That's going to be 1200, 0.1 to the power of n. And then plus the 1600. So we're going to get a minus actually here. So we're going to get 1600 minus 1600 minus 1200, 400 times 0.1 to the power of n for this sequence here. That's solving this difference equation for any an. What do we ask next? Find a4. Okay, a4. See what is 1600 minus 400 times 0.1 to the power of 4. Right, this works out to be 4 cents, so this is going to be 15.99.96. So what's happening as this power gets bigger? If you type into your calculator 400 by 0.1 to the power of 10, so if we multiply it by 0.1 to the power of 10, it's going to shift this decimal 10 places this way. So we're going to have a tiny number, 6 or 7 zeros before your 4. So it tends to 0 as the power gets bigger. So it looks like what's going to happen with this account is there's going to be pretty much a steady balance of 1600. Show that as time goes by, the amount in this account tends to a steady limit. That's actually what we're doing here now for this second one. As n approaches infinity, 0.1 to the power of n tends to 0. So that's the end of this question.